This video is to explain quadratic basics. This shape is called a parabola. A quadratic, which is an x squared, is in the shape of a parabola. These are the important information we're going to find about every parabola that we have. This parabola will keep going on forever, so there are actually arrows at the end of the parabola. The first thing we're going to look for are the x-intercepts. The x-intercepts are when y is equal to 0. The x-intercepts are when the graph crosses the x-axis. So as you can see, this is the x-axis, and the graph is crossing right here and right here. These are coordinates that we are going to call the x-intercepts. These are both the x-intercepts. X-intercepts are when you have a number, comma, 0. The coordinate is number, comma, 0 because it's when the y is equal to 0. These two coordinates are at 2, 0 and at 4, 0. So our x-intercepts are at 2, 0 and 4, 0. The vertex is the next one. This is the lowest or the highest point. Lowest or the highest point. So on this parabola, it keeps going up and up forever, so that means it will not have a highest point. That means our vertex is actually going to be our lowest point. This is called a minimum. The vertex is where it comes to a stopping point and then it goes back up. It changes. This is called our vertex. Now the vertex is actually halfway between the x-intercepts because what we do is it creates symmetry. So our vertex is going to be the x value is between the x-intercepts. So this vertex is actually at coordinate 3, negative 1. And as you can see, 3 is halfway between 2 and 4. And this is at the y value of negative 1. The axis of symmetry is what we use to show the symmetry of our parabola. The axis of symmetry is what we call it is the x of the vertex. So we always write it as x equals because it is an equation of a line and it's going to be a vertical line, so it will be called x equals 3. The reason we use x equals 3 is because, again, the vertex is halfway between the x-intercepts. Well, our vertex is actually halfway between all of the coordinates on the parabola because everything around the vertex is symmetrical on the other side. So we use a dotted line or a dashed line to represent our axis of symmetry. We call it AOS, and then we do make sure we write our equation of x equals 3. You should always, when you draw a parabola, when you are drawing your axis of symmetry, you should label it as AOS and x equals 3. This creates symmetry from all the way from the parabola to the axis of symmetry is the same distance from the axis of symmetry to the other side of the parabola on any point on the parabola. We can always go from one edge of the parabola to the axis of symmetry and from the axis of symmetry to the edge of the parabola and have the same distance. Next up, we have the y-intercept. The y-intercept is where the graph crosses the y-axis, or when x equals 0. On this case, our y-intercept is where the graph is crossing the y-axis, is right here. This is our y-intercept, and it's always 0, a number. Just like if it was linear, you'd have your 0, number. Your y-intercept is where it crosses the y-axis. For this one, it'll be 0, and it's at 8. Your y value is at 8. So our y-intercept is at 0, 8. We always determine which way it opens. And looking at the graph, you can tell which way it's opening. It is opening up because it's pointing up. But if you don't have a graph and you're looking at an equation, it's based off of the a value from ax squared plus bx plus c. So if the ax squared A is equal to a positive value, it will open up. But if the very first term, ax squared, is actually a negative, it'll open down. So the arrows will point down. So because this graph is opening up, we say it's opening up. When we talk about min or max, this comes from, is it opening up or down? If it's opening up, our vertex is at the lowest point. That means that this is a minimum. If it was opening down, we would have a highest point because it would go all the way up and then come back down. So that would be a maximum. Since this is opening up, we will say that this is a minimum because it's opening up. The value of your minimum, or your maximum, comes from your vertex because that, again, is how we know if it's a minimum or a maximum. The axis symmetry came from the x of our vertex, so the value comes from the y of our vertex. So the value is equal to the y of your vertex. So the value will be equal to a -1. And this will help us later on. The domain is always going from left to right. So for all quadratics will be like this. This graph will keep going to the left and to the right because the arrows are saying it's going to keep going up and to the left and up and to the right. So it will always go left and it will always go right. So our domain is written as, this is called an open bracket. It goes from -infinity, comma, to positive infinity, and then it's an open bracket. I'll explain open brackets in just a moment. Our range is actually going from bottom to top. Our range is our y values. So our range is actually the lowest y value we have. We always start from the bottom, is actually at our vertex, which is why we want to use our vertex. We know what our value is because whatever the value is actually going to go into our range. Now, the value was a minimum, and you always write your minimum value first. So if it's a minimum, we put the -1 first, comma, and it will keep going up forever, so it'll be a positive infinity. The brackets we want to use here, instead of an open bracket of parentheses, we're going to use a closed bracket on the -1, but then an open bracket, which is the parentheses, on the infinity. Now, before I go on and finish explaining domain and range, I want to go back to the symmetrical part, because we have the x-intercepts both of them are already plotted. Every coordinate on the left of the parabola can be symmetrical to the right-hand side. So the y-intercept actually has a mirror or a reflected point on the other side. So if 0, 8 is your y-intercept, our x-intercept is going to be the same distance away. So as you can see, we're 0 on your x value to 3, and then we'll go from 3, same amount as 3 spaces, from 3 to 6. So at 6, 8 is actually your mirror of your y-intercept. This is the mirror or reflected point of the y-intercept. This is that coordinate 6, 8. Because our y-intercept was at 8, that means that our y value still has to also be at 8. Now, talking about domain and range, going back to that, the domain is your x values. And x's are actually read from left to right. So we want to go from the smaller numbers to the bigger numbers. For all quadratics you will have, as long as it's not broken up, quadratics will go from -infinity to positive infinity. And again, these are our open brackets. We pronounce this, again, -infinity to positive infinity. This is how we pronounce it. -infinity to positive infinity. Open brackets mean that they never actually come to an end. They never actually hit a point. Because infinity keeps going forever. Open brackets show that it never stops at a point. So it doesn't stop at an actual point. Infinity is forever. That's why infinity will have the open brackets, the parentheses, because it's trying to say that it will never, ever stop. It's kind of like an open circle when you're dealing with inequalities. And then the closed bracket is very similar to a closed circle for inequalities. So if we want to talk about the range will change from problem to problem. Not a whole bunch, but unlike the domain, you will have different numbers. So the range are your y values, which you actually read from bottom to top. Because we want to go from the smallest numbers to the biggest numbers. And the bottom is where you have your negatives, and the top is where you have your positives. So if your vertex is a minimum, your range will be a very specific value. You'll actually write it as close bracket, and then you'll have your y of your vertex, comma, positive infinity. Because if it's minimum, that means it's opening up. That means it'll keep going up and up forever, so it'll always hit the positive infinities. But we have the smallest value. So we always put the smallest value first. If it is a maximum, you will actually have, so it's opening down. You're never going to end at the bottom, so it will keep going down into negative infinity. So that means we're going to have that open bracket. But then it will stop at a final point, which is going to be also the y of the vertex. But again, the y of the vertex will be a closed bracket because it actually does stop. So this bracket right here is called a closed bracket because it actually stops at a point. So when we're looking at these, we look at our graph to find these coordinates. If we're given the graph, we can easily find the coordinates. And then the domain and range, actually really the range is going to be some of the hardest parts.